Right, so today we're going to learn what pedigrees are. We're going to revise it quickly and then do a small worksheet on how to work out the pedigrees. Okay? So this topic generally students get confused with as in what are they talking about? How do we figure out if the father is affected or the mother is affected and so on. Right? So to start with, when we look at inheritance, how the traits are inherited, we divide it into two different categories, and they are autosomal or sex-linked. What is the difference between them being autosomal and sex-linked? Yeah, so if it's sex-linked, it's carried by X or Y chromosome. If it's autosomal, it's carried by any of the rest of the 22 pairs of chromosomes. Okay? And it works differently because, as we did the other day, X and Y are different. So the male has only one X, whereas the female has two X chromosomes. So that's why it works differently when it comes to sex-linked chromosomal inheritance. Right? After that, each of these two types are further subdivided into whether the trait is dominant or recessive. Yep. So if it is dominant, then even if one of the alleles is present, the person will have that trait. If it is recessive, then it has to be both affected alleles for the person to be affected. Yes? Do we all still remember that? Okay. So, for example, if we say for some trait, capital B is if it is dominant, and lowercase d is if it's recessive. So if it's an autosomal trait, then this combination of alleles would make the person affected. Yeah? This combination will surely make it affected. It's only this combination where the person will not be affected. On the other hand, if it is a recessive trait, if it's recessive, then will this combination make the person affected? No. Yeah, that's the difference. This combination will not make them affected, we know that. This is the only combination which will make them affected. Right? So this is the difference between autosomal dominant trait and autosomal recessive. Coming to sex-linked. If it is sex-linked, let's discuss X-linked first. Because under sex-linked we have X and Y. So it could be X-linked, it could be Y-linked. If it is X-linked, then we use the letters X and Y. Okay? So if it is X-linked dominant, then this is the female genotype, 2X chromosomes. When will this female be dominant? This situation, yes or no? Yes. Okay. This situation, both capital B's, yes or no? Yes. This situation, when both little D's, no. Which one? Yeah, because it's X-linked dominant. So even if the female has one allele that is dominant, she'll be affected. Yeah? On the other hand, if it is X-linked recessive, is this, we'll just look at the same thing. Is this combination, is this person going to be affected?
No.
No. This one? No. This one? Yes. Right? Now let's look at the males under similar situations. So if we have a male, they've got an X and a Y. Because the trait is X-linked, nothing's going to happen to the Y chromosome. Yeah? So we kind of ignored it. They've got only one X. X-linked dominant first. So if it is this, are they going to be affected? Yes. That's the difference. That's why we study sex-linked separately from autosomal. Can you see the difference here? See, for a female, if she's got one big D and it's dominant, yes. For this one, only one, because there's only one X, yes. If it's X-linked recessive, is this male gonna have it? No. Right? Whereas in this case, if it was X-linked recessive, again, no. Now, in this situation, let's look at the other option for the males. The X has a lowercase d. So just one lowercase d. Does it make the male affected? Yes. If the female had only one lowercase d, was she affected? No. She was a cat. Right? The third type is Y-linked. This one's easy to understand because Y is present only in males, so there's no chance of a female getting it. That's one thing. The other thing is, if the Y is affected, so if that's a male, if the Y is affected, you can put a big D or small d, whatever. So if the Y is affected, the male must get it, right? And the other thing is that the father, if this is the father and he's affected, he must pass it on to all of his sons, on to all of his sons, and his daughters will never get it because daughters do not get the Y chromosome. Yep. Now we'll look at one of the worksheets and then see how it works. Right? If you have any questions, you can ask me. All good?